So you can type it the value 1, value 2, maybe sorry. So value 2, value 1, value 2. So you see that I add to the typecasting, that's why change to the data type integer to theirs, and then so on and so forth. That's the one of the casting issues you need to be do. That's why the lower casting still you need to be converted. If you try to integer, that is okay, I think so, this is okay. But if you to detect that output as a byte value, then you need to be typecasting issues that is come up together, adding lower types. so 40 is okay. So we cover what the different type of the variables that we have. A local variable that's inside the methods. Inside the local variable cannot be static. That's true. And also we have the instance variable, and then also have the local the static variables. So static variables means it is belongs to the class. It's not belongs to the instance of the class. That's why you can directly call the instance variables that you have it here. That's all every time, and then it says every time same value when you call the classes anywhere, any part of your applications, and it got the same value anywhere, everywhere, the same value. We cannot change the value. That's why it's static variables. So we cover different variables and type of variables: the local variables, static variables, and then instance variables. And then we try different data type. Variable weighting, we already discussed this once, and also the variable typecasting from the different data types. And also we can here is the overflow of your data, and also the lower type data. How can you add the lower type data, and then you need to be cast it like the integer, or what type of variables you need to the neighbor variables, or this integer. And also if you need to really add two byte values, and to the you need to flag it byte value, and it's just work automatically. Without that was a compilation error, a plus b, and then not a plus b. It's the compilation error should have this one 40. So it says a compilation error, that's all. So we discussed the variables, the variable types, and then we discussed now we will discuss about the data types, different type of the data, primitive, non-primitive data type, and how it's important in the Vapor classes, why it is too important to Vapor class to use for the primitive data types, to convert as a non-primitive or object to the autoboxing, unboxing these things together. So go back to we write down here very simple classes. You see I defined the Vapor classes, these examples, and the static methods. So it's a void method, so it's printing autoboxing and unboxing. So we defined all the primitive data types, its values. You see the values 10, byte 10, and short value 20, integer value 30, long value, float value, double value with float value, and D, and the character value C characters, and the Boolean value B2 Boolean value. So if I try to automatically with the Vapor class, that's Vapor class means byte is a uppercase, but B short, uppercase, S integers, long, float, and double, character, and booleans. This is all the Vapor classes for the respective primitive data types. So just we put it like the Vapor class. That means the non-primitive data types, and then you see the object name. We just simply its respective byte. So it says a byte primitive type. We just put it equal to byte. That means it's automatically. That's why it's called the autoboxing. That means if you try to convert from the primitive data type to the object or Vapor objects, this is called the autoboxing. So you see the autoboxing, how it quickly works. Automatically work byte, short, integer, and long, and plot double characters and booleans. This the autoboxing automatically works. You say the printing value, byte objects, sort objects, you see the object convert on primitive to the object, byte object, sort object, integer object, long object, plot object, double characters and boolean objects, these things together. So that means every primitive data type, it has own wrapper class object definition. So then unboxing, that means you have a primitive and non-primitive data type or the objects data types, and then just simply again define your byte the primitive data type and put it the primitive data variable's name and the value of the non-primitive or wrapper class data types, and then it simply works. So that's why it's called the autoboxing. They don't need to nothing to do. It's automatically convert your primitive to non-primitive, or your primitive to the object, and then object to the your primitive values. That's the things. That's really, this is the really most important because of the your collections framework or data structure. Everywhere you need all the objects in the collections frameworks or your data structure. There is everything is object. There is no more anything about the primitive data types. Of course, it says instance variables, all the instance data types or static variables, even though there. But in the when you try to build any collections or any structure, any list or any maps or any sets, and then all things you need to be the non-primitive object class data type. So if you have, so let's have a checked, is the everything works. So we put it like all the primitive value, we try to convert is a non-primitive value object type value with the help of the autoboxing concept, and then we printed all values, and then you see the we have a primitive data types and left side, and then we have the object type data, and here the non-primitive and unboxing it this one. So let's have a check it is works or not. So wrapper class and autoboxing unboxing, this is the one of the static methods. As I said, if you delete the static method, then you have to create the instance of the object, because we define the static method that thing we don't need to create. Don't need to create the instance of the your class. So let's have it checked. So it works automatically. So you see the printing object to the your primitive to the object data types, and here this block everything is okay, and then you have the object data type to the primitive data type, everything is the same, but it's automatically, it's called the autoboxing unboxing issues. And this is the why is too important. I try to give it to you an example, like if you try to make convert to one array and then you try to make it as a list from this array. So you have input as array, that's the input value, and then you try to convert this value as, like if I go these things. So let's comment out this one. So this is tricky. This is here. Let's see that. So you have a different way of the converting the values. Let's say Java old values. Let's the commenter doesn't work properly. Let's see. So it's the collections as input. This is, I will talk about it a bit later about these things together, the collections and collectors and things together, right?